Manuel, Ava, Damari, Alia, Bella, Cole. Welcome to our math class. What are we doing today? We will look at all the questions for quiz 1.13 to see if you are struggling with any. We also have some questions from your Texas Coach book that I have added to today's lesson so we can review those questions. In case you had questions over them, we can review them. Those were some really good questions. Yesterday, in our math building blocks, we solved this question. Are there any confusions about how to solve mixed numbers? Are there any questions over how to solve mixed numbers, or are we good? We didn't get a chance to solve the third one. We can still review by solving this third question. We will solve and refresh your memory about dividing fractions. Look at this third question here. Okay, let's get started. Here in Nearpod, I have Victoria, Justin, and Alia. And the rest of us, go ahead, people. Let's quickly join Nearpod so we can start solving this question. At any time, if you feel the session is too long or you have more interesting sessions to join, you may do so. Remember, the session is recorded and you can watch the recording later if it is useful to you. Quiz 1.13. So, when I am dividing these fractions, what is my first step? What should I do first? Link to this lesson is in the chat. And I do give extra credit also during my math building block. I love to give out a lot of extra credit very generously. Those who are listening to the recording and are not part of class, you can write down your notes from the questions we will look at in class today and earn credits from me. If you bring in good questions, you also earn extra credits. Cole brought in some really good questions that I have incorporated in class. If I am solving this division question, these are right now mixed numbers. These are right now mixed numbers. I will change it to improper fraction. These are mixed numbers. I will change it to improper fraction. How do I do that? I will multiply my denominator and the whole number. 8 times 4, that gives me, how much is 8 times 4? 32. That gives me 32. And then I add the numerator 3. 32 plus 3. 32 plus 3 gives us 35. So when I rewrite the fraction, denominator is still 4 from here, and the new numerator will be 35. Any questions so far? Are there any questions so far? Very good, Liloni. When we are adding, Bella, when we add, you will make common denominator. You will not add denominators at any point. Okay. Good question. Very good, Victoria. We change it to improper. Then there is a division sign here. Can someone help me convert the next fraction to an improper fraction? Denominator is 6, but figure out the numerator. Can someone do the same process and calculate the numerator for me? And in a math class, the more you practice on your own, the more you will learn. I can be solving questions all day long, but it will be as useful as. Very good, Liloni. Bella, denominator, see, I kept this denominator same. Here, denominator is 4. The denominator in the first one is 4. The denominator is 6. The denominator is 6. I didn't do anything to denominator yet. And the numerator will be 2 times 6, that is 12. And then 12 plus 1 is 13. 12 plus 1, 13. That is the new numerator for the second fraction. Bella, does that answer your question or are you still confused? Let us know before we move on. Perfect, perfect. Okay, now the rule for dividing fraction is KCF, very good, Leonie. The rule for dividing fractions is keep, change, flip. So let's use this color. I will keep the first fraction, keep. That is 35/4. Then I will change the division sign to what sign? Change the division sign to a
multiplication.
Very good. Change this division sign to a multiplication. So it's a C right here. Change it to multiplication. Flip the second fraction. Can someone help me flip the second fraction?
Instead of 13 out of 6, it's going to be 6 out of 13.
Very good. 6/13. Another name for flipping the fraction is also called reciprocal. Reciprocal of the fraction. And to multiply these two, I will simply multiply my numerators together to get my new numerator. And to get the new denominator, I will simply multiply the denominators. Before I do that, are there some even numbers that you see in the problem? One in the numerator, the other in the denominator that can be reduced. Very good, excellent. 6 and 4. If you had 6 and 4 as a fraction over one another, you would have rewritten it as 3/2, right? In this question, 6/4 is not right on top of one another, and that is fine. I can still reduce them. 6 becomes 3, 4 becomes 2. And 35 3 times is how much? You might tell me the new numerator, people. No problem, Ranaya. 105. 13 2 times is 26. Yeah. How many 26 can go into 105? Or we can also do some division here. 105 is the top number. So top in, bottom out. Bottom number is 26. How many 26 can go into 106? 105, the actual number was correct. I totally changed the question. It should be 105. Right here. Let's see what you guys want to tell me. It is 4. That is what I was also assuming. It should be 4. And the answer should be 104 with a remainder of 1. And the remainder is 1. This remainder is actually going to create the fraction 4 wholes 1 over the denominator of 26. So that is the answer. So if I want to write down 105 over 26 as a mixed number, 4 wholes 1 over 26. Let's consider our signs. I'm going to clean out the question to see how the numbers looked like, because it is important to finalize our signs. Okay, so the first number is -8. The second number is +2 whole 1/6. Signs are different, right? when you're dividing, the signs are different. The answer, Emiliano says negative, Leloni says answer should be negative. I agree to you guys. This ultimate final answer should be negative 4 wholes 1 over 26. Any questions? Let me see. And you
Girls.
Okay. Let me look at your slides and see your work. Justin, very good. Excellent. I see all the details on your slide. Liloni, very good. I see all the details on your slide. JJ, very good. I see all the details there. Ben, excellent. Amelia and Victoria, I think you guys are working on sheet of paper. Jazzy, and that also works perfectly fine. Ava, very good. Let's move on. So from here, I'm just going to show you the questions and you guys can tell me which quiz questions were complicated and you would want me to go over. Was this a hard question? Do you guys want to see how to solve this? Let me know. You guys will have to stop me if there's a question that you want me to go over. Then this was question 2. They were simple. How about we look at one question? Let's look at this one question. So we are just sure that everybody knows how to do this. We have 5/8 divided by 9/10. I'm ignoring the negative sign. 5/8 divided by 9/10. Hello, Ranaya's brother. People, go ahead, take a couple of minutes, see if you know how to solve it. Very good, very fast, Emiliano. Emiliano did it very fast. Here, that's Liloni's slide. Very good, Liloni. That's Alia's slide. Alia, excellent. Ben, excellent. Jeremy, excellent. You guys are pretty proficient with that.
You want us to simplify it?
Absolutely. Anytime you guys see fractions, they need to be simplified. You're allowed to bring in food, drinks, take breaks as you want. Very good, Emiliano. But there's still one thing you're missing from your answer. Something that we take care of very at the end. We'll do keep, change, flip. Keep this first fraction, 5/8. Change the negative symbol to a multiplication symbol. Change. And flip the next fraction. And to flip 9/10, it will be 10/9. Are there even numbers in the numerator? One even number in the numerator that can be easily simplified by one even number in the denominator. Yeah, that is a good idea. That's Ranaya. Absolutely. So yeah, 10 and 8 can absolutely be reduced, right? If I had 10 and 8 actually over one another as a fraction, you guys would rewrite it as 5/4, right? So that's what we can do. Make it into 5/4. And then multiply. So 10 becomes a 5, 8 becomes a 4. And now when we multiply, we get, in the numerator, I have 5 times 5, 25. In the denominator, I have 4 times 9. 4 times 9 is 36. It is a proper fraction. Symbols. Let's look at the sign. The first number is negative 5/8, a negative number. The next number is a positive number, 9/10. What should the answer look like? We have different signs here. The answer should be, what should the answer look like? Should it be a positive 25/36 or negative? Ava says negative. Absolutely. It should be negative 25/36. I will pause here. So in the book pages that I received today, that I'm going to go over with you, had a question very similar. Can you write this same fraction in 2 other ways? But interestingly, in a way, although this class is a recorded one, it will not record everybody's video. It will just record maybe 4 to 5, those that I can see currently. But Ranaya, I could see you all the time.
So you want us to write on the screen what are 2 other ways to put that fraction?
Yes.
Okay.
Yes.
Well, I think I know 2 more ways.
Yeah. Ben, once you do it, you submit your answer and we will share with the class. 2 more ways that we can rewrite this one. People, can we rewrite this fraction in 2 more ways? This is extra credit. 2 more ways. And yeah. Let's see. I can have negative 25 over 36. I can also have negative by the fraction. Then I can have 25 over 36. They are different, right? Clearly, they are different. Or I can have 25 over negative 36. All these 3 mean the same. All these 3 mean the same. This is very similar to one of the questions in your Texas Coach workbook. It had one part that was asking for this. These are all the different ways you could have written it. Any questions? Please let us know. Link to this Nearpod is here. And we can move on, and you guys stop me if you need help. Now we are dividing decimals. This is also another good question. JJ.
I was just saying, like, I couldn't think of any other way because I didn't know that the placing, like, there were different places you could
Yes.
put the sign.
Yes.
So,
Absolutely. Just placing the negative sign differently absolutely allows you to change the fraction. And we have 8.64 divided by negative 0.27. I will consider both the numbers as positive, and then I will put the negative or positive sign at the very end. Go ahead, people. Show me how you would solve this question. Do you know how we can rewrite this question to make it easier and remove decimals? Let's see. Emiliano got an answer. Power of 100. Very good. Very good. Ranaya, London. Excellent. We converted. Power of 100. I agree to you. Let me see if I can get my Google Slides. That will just get me to verify answers with you guys. Go ahead, people, get started, and I'm gonna assist you with rewriting for those who are struggling a little. If I am gonna rewrite these numbers, because it has 2 decimal places and it has 2 decimal places, I will multiply each of my numbers by 100 and make it into whole numbers. I will multiply each of these by 100 and make it into whole numbers. So now what I am looking at is 864 divided by 27. That makes the problem much easier. 864 divided by 27. I'm ignoring the negative signs at the time. People, go ahead, get started. Tell me, what do you end up getting? I can absolutely go over dividing these numbers if some of you will need help on that. Okay, I will go ahead and get started. Very good, Alia. Very good, Ava. Good job, Ben. JJ, I agree to your solution. When you are dividing, the first number goes in 864 and the 27 goes out. Those of you who are dividing, I looked at your work and figured out that 327s could go into 86. And let's see, that means that is 81. 27s could go into 86. And I want to use the color red. So 3 gave you 81. And when you subtract, 86 minus 81 gives you 5. You bring down the 4, you get 54. How many 27s can go into it? Probably 2. And that gives you 54. With no remainder. That's how you divide numbers. Let's think about the sign. The first number is positive and the next number is negative. The answer will be positive 32 or negative 32. How will the answer
Negative.
be? Excellent. The answer is supposed to be negative. So the answer is negative 32. So this building block is actually set in a way so we can go over things that probably we will not go over in big mainstream class, because these are skills that we probably bring in class from our previous grade. And so the next two questions are very alike. I'm not looking forward to go over them until somebody has a question. Here we had a problem like this one. If you're in Nearpod, you can actually read the question more clearer. Starting at sea level, a submarine descended at a constant rate to a depth of -3/4. So submarine is in water. I'll just draw some water. Here we have some water. And at a so the submarine descended. Descended means it went down. Right? Descended means if you are descending stairs, you're going down the stairs. So submarine went down -3/4 mile in 5 minutes. So it went down -3/4 mile. Right? It's deep in the water. -3/4 mile. In how many minutes? In 5 minutes. What was the submarine's depth relative to the sea level after 1 minute, after the first minute? So in 5 minutes, the submarine went down -3/4. How much did it actually go down in 1 minute, in that first minute? What operation do we do here? Amy, that's actually a good idea. What operation can we do so that we can find for 1 minute? In 5 minutes, we will do division. The submarine, in 5 minutes, the submarine descended, means went down, -3/4 miles. in 5 minutes. So to find for a minute, 1 minute, we should divide negative 3/4 by 5. And 5 is the same as 5 over 1. I'm not going to go over teaching you how to divide unless someone will ask me to teach them to divide. And let's look at the next question. Is it very similar? So at sea level, again, very same, different numbers. Definitely you can handle this one. It is dividing by 4. Third one, I'm anticipating again another submarine in 3 minutes. So you're dividing by 3. We won't go over this. Then another quiz question says, a chemist recorded the change in temperatures of a cooling liquid as negative 25.5 Fahrenheit over 1.5 minutes. So the temperature changed negative 25.5 over how much time? Over 1.5 minutes. The temperature fell at a constant rate. That means it changed at the same rate. What was the rate of change in temperature? When they're asking you rate of change, they mean to say how much did the temperature change each minute. When they're asking you for rate of change, this is something you can write down. Rate of change, we will look at it in more detail. They're asking you how much the temperature actually changed per minute. That is what rate of change is. So again, I can divide 25.5 by 1.5 minutes, and it will tell me how much the temperature changed each minute. Here I have decimals. Can someone guide me how I can get rid of these decimals? Can someone guide me how I can get rid of decimals? Very good, Ben. Very fast, very quick, very accurate. I have 1 decimal and 1 decimal. I can multiply both of these numbers by 10 and make my calculations neat. When I multiply these numbers by 10, I'm actually trying to get rid of these decimals, and I get a number that is 255, negative 255, divided by 15. And this will be much easier for you to divide than the decimals. When you have 1 decimal in both the numbers, you can multiply it by 10. When you had 2 decimal places in both the numbers, you can multiply by 100. Does someone want me to go over division with them, or you guys all know how to divide the numbers? Very good, Liloni. That is how you set it up. Okay, Amy, let's see. I got rid of the decimals. I have 255 and 15. If I set up my division, I have 255, the first number in, and 15 over here. How many 15s can go into 25? 1, with a remainder of 10. Now, I have 105. How many 15s can go into 105? 7. And it gives me 105 with no remainder. So, Amy, it should be 17. We got rid of decimals already. And it will be a negative answer because we're multiplying a negative number by a positive number. Different signs. Okay. So the rest of these questions will look very much like this. I do have some book pages, Texas Coach pages. Kind of looks a little dark. I will read it to you, and you probably have the Texas Coach book, and this lesson is for this week. An electrician needs to buy 12 hole 3/5, 12 hole 3/5 yards of electrical wire. This electrician needs 12 hole 3/5. He needs. There are 3.5 yards of wire on each spool. On each of this electrical wire bundle he buys, each has 3.5 yards, right? Will the electrician only buy one spool? Will the electrician need only one spool? No, the electrician does not need one spool. One spool has 3.5. The electrician will need more spools. We will divide 12 holes and 3/5. We will divide this into 3.5s, so we can calculate how many spools the electrician will need. We will divide so that we can calculate how many spools the electrician will need. That is the best way to find. So if you want to see in a picture, the electrician needs 12 and 3/5 spools, right? And 12 and 3/5 yards, and I'm going to label that as 12 and 3/5 yards. That's what the electrician needs. His need. One spool, like one bundle of the wire, has only 3.5 yards. One spool has only 3.5 yards. So how many of these spools, how many of these 3.5 spools does this electrician need so that he will have 12 hole and 3/5 yards? This is a division question. Let's see, anybody got to solve this? Very good, Ben. Let me see, is that what I got? 10. Excellent. Excellent, excellent. Ben believes we get 4. And that is a division question. We have learned how to divide. I'm expecting we will be able to divide from here. If you think you need help with dividing, you can let me know and we can divide. Cole, do you want me to divide and tell you the answer, or is this much guidance good enough? Because the goal is that you guys practice. The goal is that you guys practice. And let me know if you guys will need some more details. The next question in the book looked like this. If you are in Nearpod, very surely you can see a lot better. So question 7, find the quotient. And there are 3 fractions being divided. A good idea in this question will be, any ideas? How would you solve a question like question 7? It has 3 numbers that are being divided, and I can write it out here.
Since
so everybody knows. Yes, go ahead.
since the first two numbers are in parentheses, you do those first,
Excellent.
and then you pretend like now those are both one numbers, so you're able to divide by the next one.
Excellent. We will divide the first two numbers, 5 1/2 by 2 whole 3/4. We will divide these and get an answer. Then we will divide the answer by 1 whole 1/2. So step 1 should be to do this part. Anytime we see parentheses, that part needs to be solved first. When I divided these two, I ended up getting -3/2. Let me know if you need help with dividing the mixed numbers. Let me know if we need help with dividing the numbers, then I can go over in more detail. And Deloni already got started. JJ did too. Very good. It is a good idea that you start writing with improper numbers, fractions. I got this for the first part. Then I'm going to copy the remaining question. Then I will divide it by and look at this next one. I'm going to write as a mixed number. 2 times 1 is 2. Then I add the numerator 1. 2 plus 1, right? I get the new numerator that is 3. I'm going to pause here so that I can see. No problem, Alessandra. Perfectly fine. This session is not a required one. It is optional, but it is really good that you join. You will learn some good math. Can someone tell me if I divide a number by the same number or by itself, what do I end up getting without doing calculations? Look at my screen.
0.
0. So 5 divided by 5 is 0. How many 5s go into 5? 1. And these fractions are exactly alike. When I divide them, I'm not going to apply any rule. I know the answer is supposed to be 1. How many 3/2 can go into 3/2? 1. And then think about the sign. The first fraction was a negative fraction. The second fraction is a positive fraction. And the signs of the two fractions are different. And with different signs, when you're dividing or multiplying, the ultimate answer should be negative. These are the kind of questions that were on your math workbook, Texas Coach. You all got a math Texas Coach book? Yes?
Yeah, I did.
Yeah.
The science teacher still hasn't gotten her package for
Yeah.
with all the science stuff.
Yeah. And Ben, same here. I haven't gotten mine. So we had a classmate who had questions over these questions. They sent me and I requested them pictures. So they sent me pictures and that is how I could incorporate them in my class. To send me pictures and I added those pictures to the slides. I haven't received the book, so I couldn't help anybody if you guys had questions. But if you'll send me pictures in the meanwhile I receive my book, I can help. So these are some really good questions. We still have 5 minutes. This week, class is 45 minutes. Next week, we can have a class of 1 hour.
So on my slide, it says -1, but I didn't have enough time to put -1 and 1/3. Just so you know.
You didn't have you have a different answer?
No, my answer is -1 and 1/3 because that's what I got.
Okay, we can look at your work. So the very first one is 11/2 times. Okay, I see the error, Jeremy. This one, the second fraction, is 11/4. Okay. Oh, okay, you get 11/4. Absolutely. When I solved this one, I messed up. Let me see. You got 11 and 11's cancelled off. So that's 4/2. That is 2. I agree to you. I didn't use the correct KCF thing when I was doing the first part. Very good, Jeremy. I greatly appreciate that. So this part is where Jeremy got a different answer. Did anybody else also got a different answer than me? That does happen. Did anybody else also end up getting a different answer than me? In this very first part, the parentheses part?
Sometimes I get a different answer from you, and it's literally like one number off. Like today, it
Yeah.
was 320 instead of 220.
Ah, 200. Was that the, let's see, this is 10, 11, 11 over 2. I'm going to do times. I'm going to do KCF here. 4 should be the numerator, JJ. This is where I messed. You know, I put my numerator as 3. That is where I went wrong. And that's 8 and that's 11. That is the first part if you are solving after applying KCF. Then, absolutely, you can reduce numbers and the 2 becomes a 1. 4 becomes a 2, right? And the 11s become 1. 11 divided by 11 is 1, and the 11 becomes a 1. So now in the numerator, I have 1 times 2 is 2. In the denominator, I have 1 times 1 is 1. And then I divide by 3/2. And then I can do the KCF and the answer is slightly different. And this is also negative. Absolutely, JJ. Thank you for correcting. This does happen. I am not cross-checking my own work. It is a good idea that sometimes you guys can cross-check my work. And that is 2 over 3. When you multiply, you do end up getting -4/3. And -4/3 should be -1 1/3, not 1. -1 whole and 1/3. Absolutely. And I greatly, greatly appreciate you for correcting me on this. Let's look if we have one more question. We don't have enough time to cover this one. We actually have 2 more.
Miss, can I ask you a quick question?
Yes.
It isn't math related. I just want to know.
Go ahead. I'm going to see if I can answer.
Every time we play Time to Climb, we choose a character.
It's a character.
There's a penguin. I'm making a penguin revolution.